Hello, this is part 2 of a prior video. What I have here is a 300 watt grid tie inverter that's 12 volts, and I'm operating it off a pair of grid tie panels that their power point is at around 60 volts. What I did was I bought a whole bunch of grid tie inverters that were broken, and at camp I have a couple oddball 12 volt panels, but at home I only have these grid tie panels which are about 60 volts, and I wanted to try and use them. In the prior video I showed how to control the small buck inverter that will take up to 72 volts and is rated at 180 watts. Most grid tie panels you don't want to get beyond almost half their rated power, otherwise they overheat and become less efficient. But this has a basic circuit that looks at the input panel of the voltage of the panel, and if it's over a certain voltage it turns off the grid tie inverter. If it's under, it raises the voltage. And this is all built into spare space that was inside the module box. As you can see right here, we're bouncing around between 13 and 16 volts. The grid tie inverter is searching for the power point right now, so that's why it's moving a bunch. But you can see that it's being held very closely at 55 volts. Now the power supply is set to 20 volts maximum, but as you can see it's being throttled down by the control electronics. The circuitry is very simple. It uses a TL431. The reference voltage on a TL431 is about 2.5 volts, and so any voltage divider, if you have 36 volt panels, or say you had a 36 volt system which is around 50 volts, you can adjust the voltage divider to get whatever voltage you want. You don't really need to operate MPPT. This is really an MPPC system. The voltage of the panels only changes with temperature, and then it doesn't really change that much that you have to really worry about it. If you set this thing 4 times a year with each season, that would be sufficient. And right out here what we do is we feed into the buck converter this signal into the LED of the opto input. So as you can see, it's a fairly simple circuit, and this can, with slight variations, can be used on any buck converter to create the voltage you want. This makes a nice linear current booster for if you have a pond aeration system and you don't want to use a battery with it. These little converters are good for about 10 amps each, but you could actually multiply up the number of you could have 2 or 3 of them in parallel to get higher currents. And considering they're only at about $6 each, that's a pretty cheap system. So I'll let you have another look at the schematic, rewind it and look at it. But this is the most useful thing that you can have in solar, being able to hold panels at power point. Thanks for listening.